Hi, this lecture is a lecture where we are going to discuss the fifth chapter of Blanchard's book, and this chapter it's an interesting chapter. It's the first time that we are going to present the ISLM model. This is going to be an introduction of the ISLM model, and in this introduction we are going to, let's go to this slide here. First of all, we will discuss the goods market and how this can derive the IS relation. And the same thing in the financial markets and how this can create the LM curve or the LM relation. Then we put these two together, and then we will have the equilibrium in that market. After that, we can change the equilibrium through some policies. We're going to use the fiscal policy and the monetary policy. So, in the third chapter, we have discussed how the goods market determines the output. And the output was the variable y in our model. In chapter number 4, we have discussed how the financial markets determine the interest rate. That is the letter I in our model. Now we're putting together these two markets, the financial and goods market, and then we are going to determine with the ISLM model at the same time both the variables y and I, output and interest rate. This is a curiosity here. This name ISLM was given by both John Hicks and Alvin Hansen. We start with the following. We have discussed in chapter number 3. If you remember, the demand was composed by C, I, and G, right? Consumption, investment, and government expenditures, and we don't have the net exports because we are dealing with a closed economy. In that chapter, we said that this guy, not only this guy, because this guy is also an exogenous variable. However, we just said that I was uppercase I. Now we are going to say that the investment function, which is the equation 5.1, is going to be a function, and this is, this is again the same thing as before. We are not giving here any functional form. We are just saying that the investment is a function which responds positively to the output and negatively to the interest rate. The underlying reasoning for these two signs here is very straightforward. Well, as the production increases, then there will be more money to be invested. So when the production increases or the sales increases, the capital owners will be willing to invest more money in the production. However, sometimes the money that is used to invest must be borrowed. You must go to a bank to borrow some money. And when the interest rate goes up, you will be less willing to get that borrow. So, if the interest rate goes up, the investment goes down. So, plus and negative here. We had, as I wrote in this slide here, the demand function in the discussion of the goods market, if you recall it. It was Z for demand equals to C plus I plus G. And then we have this equilibrium condition where the demand equals to the income or the output. And then there's the equilibrium condition where Z equals to Y. Therefore, just substituting here Z, putting Y here, we have Y equals to consumption plus investment plus government expenditures. However, we are using two two definitions for two of the variables. So the consumption is a function of the disposable income, which is the income minus the taxes, and the investment is this implicit function of the output and the interest rate. This is going to be the IS relation, this guy here. If someone asks you, okay, what is the IS relation mathematically? This is the IS relation. How this works graphically? Well, we start with the following. We start with this equilibrium in the goods market. This equilibrium in the goods market was, let me see something here. Yeah, this was the graph. And we have in the next slide some explanations why this graph is in this format. First of all, ZZ is an upward sloping curve because, as you remember, for a given value of the interest rate, an increase in the output leads to an increase in the demand for goods through its effects on consumption and investment. So if you see here, if these two guys increase, this guy is going to increase. So let's go back here. For a given value of the interest rate, an increase in the output leads to an increase in the demand for goods through its effects in consumption and investment. So we have Y here, we have Y here, this is going to increase Z. As Z equals to Y, this is going to increase Y. That's the first reason why we have this, this is going to, why this demand is an upward function, upward sloping function or curve. Second thing, this is flatter than a 45-degree line, and this is because of the assumption of the C1 that we have made. Because we have assumed that an increase in output leads to a less than 1-for-1 increase in demand. And this is obvious because the propensity to consume out of the income is not 100%, but it's something positive. So the slope of this curve is going to be less than 1. The last thing is the intersection between the ZZ and the 45 line is this equilibrium here. Z equals to Y. Z, and this is going to give you Y with the output here. All right, this is the thing that we have discussed 2 chapters ago. How the relation in this chapter, the IS relation, is derived. So first of all, the book describes in this way. An increase in interest rate decreases the demand for goods at any level of output, leading to a decrease in the equilibrium level of output. B. Equilibrium in goods market implies that an increase in the interest rate leads to a decrease in output. So this is a bit weird to understand, so I want to show you step by step what happened. What happens is the following. We start with this equilibrium, which is the same thing that we have here, okay? There's nothing new, it's just this graph here. We start with this guy. And we say the following. Let's say that the interest rate is going to increase from, let's say, Y, from I to I prime, okay? When the interest rate increases, then we go back to this guy here. When this guy here, the interest rate increases, we have a minus sign over there. This negative sign implies that when the interest rate goes up, the investment goes down. When the investment goes down, the demand goes down. So what happens here is when we have a higher level of the interest rate, the investment goes down, and therefore the demand goes down. So this curve shifts down. Right? What we have here? Well, in the first case, in this first equilibrium, we have the determination of the first output here, Y. However, in the second case, when we do this change, we have a new value for the output, which is Y prime. Right? What happens? What's the underlying reasoning here, or the underlying process here? Well, the interest rate goes up, and the interest rate goes up, making the investment to decrease. Let's call this guy A and this guy A prime. They are just two equilibria in this graph. A is, we have another graph here, which I am stacking over the first graph. Why I'm stacking these two guys? Because they have the same x-axis, so I can put one above the other, right? With this first, let's continue here. If they have the same x-axis, so let's make the x-axis match. Oh, sorry. Much better. Right, so we have here y and y prime. They are the same y and y prime as we have in the demand schedule in this first guy here, right? What happens in letter A? In letter A, we have one specific level of the interest rate. Let's say that this level gives us this point here, which is the interest rate I. What happened in this, why we have a new equilibrium? This new equilibrium comes from the increase, so this was point A, the increase in the interest rate. So let's say that the interest rate here, I prime, is here. It's a higher level. This higher level gives us a new interest rate. However, this interest rate brings down the investment, which makes ZZ to go down, and the equilibrium is Z equals to Y. If Z goes down, Y must go down. So this Y prime is associated with a lower level. Sorry, let me start all over again. This lower output, Y prime, is associated with a higher interest rate. So this is going to be A prime. And when you connect those dots, you have this downward sloping curve here, which is called IS. How do someone derive the IS curve? We start with the demand schedule here, where we have the demand and the 45-degree line. Then we change the interest rate. As the interest rate will change, this is going to impact the investment. The investment impacts the demand, and the demand in equilibrium equals to the value of the output. As the demand goes down, the output goes down. So we have this negative relationship between the interest rate and the output. So if you calculate the derivative here, di dy is lower than 0, and this is referred to the slope of this curve, right? Something that's very important here. We have DIS is written here, which is the same as, if you go back here, you can double check, is the same as this guy here, okay? So this is the IS curve. And this curve, well, why this is IS? If you have any questions, remember that it was Z equals to this entire guy here. And as Z equals to Y, you plug Y over there, and therefore you have the equation, okay? What are, and this is the first thing that you always must have in mind, what are the variables that I'm working with? Well, we can have exogenous variables and endogenous variables. Exogenous variables are the ones that are defined outside of the model, not within the model, while the endogenous ones are the ones that are defined within the model. In this case, we have assumed that, let me choose different colors here. Well, what is given by the outside? Well, we are not modeling the taxes, and we are not modeling the government expenditure. So the taxes and the government expenditure, they are both exogenous here. What is endogenous here? Well, what is endogenous is everything that is defined by the model. What is defined by the IS curve? What the IS curve defines? At the same time, the output and the interest rate. So the output and the interest rate are endogenous variables. So this is endogenous, which is the same thing. This is endogenous, and this is endogenous. As you can see, we don't know what C and I are. We know they are function of, in the investment case, the investment is a function of two endogenous variables. So a function of endogenous variables will be endogenous as well. Because these guys are defined by the model, therefore this guy will be defined by the model. However, here we have two different colors, right? The blue and the red one. It is straightforward to think the following. Even though T is given by the outside of the model, not by the model itself, when the output changes, the consumption function will change. So the most strong variable here is this is a simplification to say the most strong variable. So the variable that defines if the consumption is exogenous or endogenous is going to be that a function of an endogenous and exogenous variable will be endogenous. So consumption is endogenous. So as you can see in our model, so this guy will have the blue and this guy will have the blue as well. In our model, let me delete this guy because there's nothing endogenous here. So in our model, we have the IS curve, which is y equals to consumption, which is a function of disposable income, which is income minus the taxes, plus the investment, which is a function of the output, plus, not plus, but the investment is a function of the output and a function of the interest rate. It's better to say like that. And the government expenditure, which is something that comes from the outside. Someone gives us one number and says, okay, the government is spending X dollars, right? So in our model, T and G are exogenous and all the other are endogenous. We have something called comparative statics. Comparative statics is an exercise, and you do the following in this kind of exercise. You will start with an equilibrium, and in that equilibrium, after you achieve that equilibrium, you ask yourself the following. If I change either an exogenous variable or a parameter, what happens with in this new equilibrium with the endogenous variables? So what I'm saying is the following. If I change either T or G, using this formulation here, right, this IS curve, if I change either T or G, what happens with Y and I? And therefore, this is going to define what happens with I and C, right? So what I'm saying is that this is going to be shown here, but when I change the taxes as here, not here, here, this is going to make the IS to shift. But before we jump into the graph, sometimes some people prefer to write down, instead of using C of Y minus T, they prefer to use that linear relation that we have discussed before, which is C naught plus C1 times Y minus C1 plus, times T. So here, let's investigate which of them are endogenous and exogenous. Let's start with the exogenous one. So T is exogenous and G is also exogenous. However, we have some parameters here, C0 and C1. Are they defined by the model? Is it the model, the IS curve, giving us any C0 and C1 values? No, it is not. Therefore, the parameters here are also exogenous variables. And the endogenous ones are the same. The output, the interest rate, investment and government expenditures. Sorry, consumption. So those are the two possibilities of the IS curve. This one is also the IS, okay? This guy here is also the IS. The only difference is that I am using here the linear consumption function. Instead of having this C of y minus t, we have this C1y minus C1t plus C naught. So let's see what happens when the curve is shifted. When the curve is shifted, let's use this example here. Well, the example is the following: an increase in taxes. Why this is going to shift the curve? Because we are using the movement of an exogenous variable. When an exogenous variable is changing, we will change the position of that curve in the economy, sorry guys, we are going to change the position of that curve. Excuse me. We are going to change the position of that curve in the diagram. So here we are considering that the taxes are increasing. Well, when the taxes goes, when this t goes up, this makes y, sorry guys, c of y minus t, as t is going up, c is going down. As z equals to, well, you already know that the IS function is y equals to c plus I plus g. As c is going down, the output will go down. Therefore, when you increase t to t prime, you have this reduction of the equilibrium output. This is what happens when you increase the taxes in the economy. Well, as people will have less money to consume, the output of that economy, therefore the GDP of that economy, will shrink. Why this curve is a downward sloping curve? Well, you can think about this derivation here, which is a mathematical and graphical explanation. Or you can think that the equilibrium in goods market implies that an increase in the interest rate leads to a decrease in the output. Well, you have this guy here, which is the IS curve. And if I am here in point A, I have I naught and Y naught. And here it says that an increase in the interest rate. So let's do the following. Let's do the decrease in the interest rate, just to be consistent with what I have drawn with the graph here. A decrease in the interest rate to, let's say, this point B here, which makes the interest rate goes from I0 to I1. This makes the output goes to Y0 to Y1. So a decrease in the interest rate implies an increase in the output, and the opposite also holds. An increase of the interest rate makes the output to reduce. What's the shifting of this curve? Well, we changing factors that decrease or increase the demand for goods given the interest rate shift the S curve to the right or to the left. As you can see here, when we move the taxes, we are not changing the interest rate. So the reasoning is something like that. We have here the interest rate. The interest rate is given in this level, and here we have the IS curve, right? When we change the taxes, we are not changing the interest rate. The interest rate is the same. The taxes are just, in this case, let's say that I reduce the taxes. Therefore, we have this movement of the shift of the IS curve to the right. I have something that's very important here. Either in macro or in micro or macro, either one, you have to differentiate between what is a movement of the curve, which is considered a shift and what's the movement along the curve? Well, let's start with this point A here, this guy here. In point A, we have this given IS. This point establishes both y and I naught. What's the movement along the curve? Well, let's get this point B, and this point B, without changing the curve, will give me a new combination between the interest rate and the output. If we go from A to B, we can say the following. In A, we have y and I naught. For a greater output, y1, we need a lower interest rate, I1, or for a lower interest rate, I1, we need a greater output, y1. Okay, so you can think about this combination. As this curve is a downward sloping curve, to have a greater value in the x-axis, you must reduce the y-axis variable. What happens, however, if we keep this I naught? Well, if we keep this I naught, and let's say that we change the taxes, as we had before, for the same interest rate, we have a greater value of the output, right? So a shift of the curve is keeping one of the variables and showing the other increasing. A movement along of the curve keeps one of the variables and the other variable. And when you talk about the new variable, you are changing both of them. So this might be confusing, and let me say this more clearly. What I'm trying to say to you is the following. Movements along of the curve implying combinations. In this case, combinations between y and I. I'm putting this pair notation here because it's like x and y, okay? The x-axis is the y and the y-axis is I. What's the meaning of movements of the IS curve? What's the meaning of a shift of a curve? If you go back here, shifting the curve makes the movement given the interest rate. So we are not changing, the pair. So when we shift the curve from A to A double prime, or the IS from IS to IS prime, we have the first equilibrium is the interest rate 0 and the product 0, the output 0, and the new equilibrium, we have the same interest rate, but we have a greater output. This is the same as to say a movement along the curve does not imply any change in the structure of the model that we are working with. We have the model given, and we are just discussing what happens if we move from one point to another point along of that curve, and to have different points we need to come up with different combinations of the endogenous variables here. However, when you have the shift of this curve, you are saying that I am expressing how the model can give me a greater value of one of the variables without changing the other. So that's why it is important to understand what makes a curve to shift, right? We already know what's the IS, or the first side, the first part of the model, which is the IS-LM model. So we have to discuss the LM part of the model. What is the LM relation? Well, we start with the financial markets, and we start with this equation here. M equals to monetary sign Y, which together they mean the money income, right? It's a nominal variable, multiplying the L function, which is a negative function it was negative here, a negative function of the interest rate. We are going to get this equation and we are going to do the following. We have m equals to YLI, and we are going to divide both sides by P, okay? And then we are going to have that m over P equals to S y over P times Li. If you remember what I have told you before, when you have a real variable, that real variable is the nominal variable over the prices. So the real output is the nominal output over the prices. Therefore, this guy, which is what we have here, right? You can put m over P equals to YLI. And this is the definition of this equation 5.3, which is going to be the LM relation. Well, in equilibrium, the real money supply, and this real here is because we are dividing the money supply by P, the general price index. The real money supply equals to the real money demand, which depends on the real income and the interest. If you want to clearly understand and remember what's happening here is that we have MS equals to M, MD equals to SYL, right? And then because MS equals to MD, we have that M equals to this guy here. So we are in the equilibrium of that market, then we divide by P, and then we have this equation here, okay? So this is the LM relation. This equation here is the so-called LM relation. What is the LM curve? Well, the LM curve, now you forget everything that we have discussed in the last chapter, chapter number 4, about how the government changed the money supply and this endogenously defines a new interest rate. Now you think about the following. We are using the reality. What happens in reality? The central bank chooses the interest rate. So the LM curve is going to be the following. Let me say that the LM curve is implying that the interest rate is going to be a given level of the interest rate, right? So we put in the same YI. We have already done the IS, and now we are adding this straight line, which is the LM, and this LM represents this guy here, I bar, right? So this is going to be a ISLM model. This is where we put everything that we already discussed in one slide. What's the IS relation? Well, the IS relation comes from the equilibrium in the goods market, which is Y equals to C plus I plus G, with the respective formulations for consumption and investment. The LM relation, it is established by the level of the interest rate chosen by the central bank. They together will determine the output. As you can see here, they together determine the output. And I'm going to put this star here just to say that this is the equilibrium output, right? So this is the third bullet point here. They together determine the output. Any point on the downward sloping IS curve corresponds to an equilibrium in the goods market. So when you go, let's stick with this one. Both in A and A prime, the goods market is in equilibrium. Why? Because here we have Y equals to Z, and here we have Y prime equals to Z prime. Therefore, they're both equilibria. So when we have, let me see, where are we here? When we have the IS curve, any point along the curve represents the equilibrium in the goods market. Any point in the LM curve is going to represent the equilibrium in the financial markets. It's the same thing. Only at the intersection, which is the point A here, here, this one, only at this intersection, both are in equilibrium at the same time. So let's say that we have this point here. What happens here? Well, we have the equilibrium in the goods market, but we don't have this point over the financial markets, so we cannot say anything about the financial markets. The same holds for here, 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 and any other point that you may choose along any of the curves except this guy here. This guy, at the same time you are over the financial markets curve, you are over the goods market as well. So this is the equilibrium in both markets. What's said here is the following. Equilibrium in the goods market implies that an increase in the interest rate leads to a decrease in the output. As we know from A to A prime, we have I naught and I1, and here Y naught, Y1. So a decrease in the interest rate represents, let's use the same they are using here. There is increase. So let's put 0 here and 1 here. Let's start with the lower, and this is going to be A prime. So an increase in the interest rate represents a decrease of the output, increase and decrease. This is represented by this IS curve, and I would add by the downward sloping curve, right? Equilibrium in financial markets is represented by the horizontal LM curve. Only at point A, which is both curves, it's on both curves, we have the equilibrium in both markets. Let's put them together. Well, I have anticipated to you that this happens, this is the graph that when we put them together, or here you have a better a diagram that it's a bit better, but we can go further. When we put them together, we can think, okay, I know that the equilibrium is represented by the intersection. However, you have said that, you told us that you can shift the curves, right? So what happens when one of the curves is shifted? Well, we can have something called fiscal policy. And in the next slide, in a couple slides, we will have the monetary policy. So let's see, first of all, what is the fiscal policy? Well, the fiscal policy is you have either an expansion or a contraction of this policy, of the fiscal policy. If you are expanding or increasing the fiscal policy, you are increasing the government expenditures or decreasing the taxes. This is interesting to think, what's the fiscal policy expansion? Well, you are expanding, you are making something to grow, and this will imply that the output is going to grow. If you go to the equation, which is the IS equation, we have Y equals to consumption plus investment plus government expenditures. So when this guy goes up, the output goes up. Therefore, the fiscal expansion is what is done by the government to increase the output, the short-run output. So the fiscal expansion is either or both the reduction in the taxes and the increase in the government expenditures, and the contraction is the opposite. So if the government wants to reduce the output, they can either increase the taxes or decrease the government expenditures. However, you can think about the combination of both T and G here. If you have, so what's G minus T? Is what the government, this is the opposite of the government savings, but don't bother yourself with that. A fiscal contraction, which is this example here, is the same thing as to say that we have the fiscal consolidation. But to have the fiscal consolidation, we have to have a decrease in this relation here. So G minus T equals to, let's say, 10, and then G minus T prime. So something is happening within this parenthesis. I don't know which one is changing. And this is leading to, let's say, 8. Right? So a decrease in this combination of G and T is a fiscal consolidation. So I like to think about them separately, like this. And when I want, so the fiscal policy is either the expansion or the contraction, just thinking about either the G or both G and T. And the fiscal consolidation, it is when this combination between G and T within this parenthesis, the result of this parenthesis decreases. And the opposite, it's obvious, but the increase in G minus T is the fiscal expansion. Well, when we put both of the curves together, we can analyze the effects in the policies, or, as I told you, the comparative statics, which is how the exogenous variables are changing. So what we can think about? Well, does it shift the IS or the LM curve? This is the first thing that we have to think about. I'm changing something exogenous. Well, is it changing something in the IS or in the LM side of the market? The second thing, what does this change do to the equilibrium output and to the equilibrium interest rate? And the last thing is to describe this in words. Here what we have this point A representing the LM and the IS in the very beginning of our exercise. The comparative statics here is going to be the following. We start with you always start with an equilibrium, okay? So we start with A, which is the equilibrium, which is giving us this Y and I bar. These two guys are the combination, so you can say the equilibrium of this economy is defined in this case by this pair here, right? This is the equilibrium. Let's put here A. And then you have, in this case, an increase in taxes. And as you remember, when the taxes goes up, the consumption, which is a consumption, is a function of the disposable income. As the taxes goes up, you have less money to use. Therefore, your consumption is going to fall. When their consumption is reduced, the output is reduced as well. So you have this shift of the curve to the left. Therefore, the IS is shifted to IS prime. As you can see, this leads to a lower output, and the equilibrium in A prime is comprised by this pair here. Okay? Let's see the monetary policy here. Well, the monetary policy is the policy that we do in the LM curve. So this is something that I would like to write down here so you don't forget. The fiscal policy is linked to the IS curve. The monetary policy is linked to the LM curve. If you have, in this case, let's start with the following. You have a decrease in the interest rate. So the central bank decides to define a lower level of the interest rate. This part here, let's forget this for a while. A decrease in the interest rate is an expansion of the monetary policy, and an increase of the interest rate is a contraction of the monetary policy. And this is really straightforward. When the interest rate goes up, you have the LM curve, which is M over P equals to Y L I, and this guy is negative. When you have the increase in I, you have the decrease in M over P. So an increase means a contraction. Okay? And how you can think about what happens with money, because this might be tricky. So remember that monetary market discussion. We have the money demand here, and we start with I naught. In I naught, we have the equilibrium, which is the point A, defining I naught and M. When you have a reduction of the interest rate, when the interest rate goes from I naught to I1, you don't change the interest rate, you don't change the money demand. This is given. And what's happening? You have a lower level of the interest rate. How this is adjusted? Well, the adjusting variable here, in this case, when you exogenously defines the interest rate, you endogenously have the adjustment of the money supply. So in the first case, you have M here, and when you have this reduction of the interest rate, you must have the movement along this curve to this new equilibrium here, B. And then you have the increase of the money supply. So this decrease here implies an increase of the money supply. A decrease implies this increase in money. Okay? So I like to think the following: monetary expansion equals to decrease in I, and monetary contraction implies in the increase of I. And then when I increase or decrease, what happens with the money supply? Well, as you have this negative relationship between both of them, when the interest rate goes down, you have money going up and money going down. So I prefer to establish what's a contraction and expansion in terms of the interest rate, and then you see what happens with money, because starting with this relation might be confusing. So what is a monetary policy? It is a policy that the central bank decides which is going to be the level of the interest rate. With that, two things occur. The first of them is you can say that if the interest rate goes up or down, you can say if this is a contraction or an expansion in the monetary policy. And you can also say what happens with the money supplying the economy. So these two things are connected, but you can think about them separately. You have here the following. We are trying to show here the reduction of so let me write down this here. LM is I equal to I bar. So in the LM curve, we just have an exogenous variable. We don't have any endogenous variable, right? The LM is not, because the LM, it's just this thing here, right? This is the LM. As you can see, we are not determining with this curve, with the LM curve, we are not determining which is going to be the output. Is this one? Is this one? We don't know, right? So we only have the exogenous variable, which is the interest rate. In this case, equals to Y bar, right? So when we do a change in the interest rate, which is a change in the exogenous variable, what happens with the equilibrium? This is what we are trying to do here. Well, in this case, we have a monetary expansion. Well, monetary expansion, which is the same as to say a decrease in the interest rate. So when the interest rate goes down, for a given IS curve, I'm not doing anything with the IS, there's no fiscal policy happening here. What happens with the equilibrium? Well, we have a greater, first of all, you reduce the interest rate, which shifts down the LM curve, because the LM curve is defined by the interest rate, and then this is going to lead to a higher output, okay? Using the mix, you can use at the same time a fiscal and a monetary policy. So the monetary fiscal policy mix is the combination of both of them. And let's start with the following. So let's suppose that the economy starts in a recession, right? How can you use both policies to make the things better? Well, you can do the following. Let's see this. Let's start with my example here. So here I have we always start with an equilibrium, right? Remember that. And we have, but as you can see, the Y is a very low level. Let's call this recession for a while. We are in an equilibrium, and this equilibrium is a recession. We want to improve the output of this economy. What can be done? Well, we said let's use a mix of the policies. Let's start with the fiscal policy. Let's call this number 1 and number 2. Let's do number 1 first of all. We start with the fiscal policy. And then what can be done in terms of the fiscal policy to improve the output? Well, you can think about the following. You have this curve here. If I want to improve the economy without changing the LM for a while, if I move the curve here, I'm going to have a greater Y. If I move the curve here, I'm going to have a lower Y. So it is obvious that we are going to do a fiscal policy, which is a fiscal expansion, right? This fiscal expansion is going to be, let's call this IS prime, and let's say that this is an increase in the government expenditures, okay? So we have this expansion for this new level of output. It's going to be this guy here. However, can anything be done with the LM curve or the monetary policy? Can the interest rate be changed to improve the economy? So let's think about this guy. Well, we start here. If we move this curve up, this new LM curve will encounter the new IS curve, in this case, in an intermediary output between Y and Y prime. This is not what I want. I want a greater output. What happens if I reduce the interest rate? Well, here we have exactly what we are looking for. This new equilibrium, which is going to be this guy here. The first one was this guy here. I'm going to call this guy B. And in this guy B, we have this new level of output, Y double prime. So, first of all, the fiscal policy. So let me just write down this. And this is an expansionary monetary policy as well, because we are decreasing, in this case, the interest rate. Okay? We started with the fiscal policy. So the first thing we do is this jump here. Let's call this, to avoid confusions, let's call this S, right? So this is S, and when we do the monetary policy, we have this guy here. Let's call this R, S and R, right? What happens if we do the opposite? Let's think about starting with the monetary policy. This is going to be the same thing, but you have to think in a different way. So, the same thing, we start here and we ask ourselves, if I increase the LM curve, so if I increase the interest rate, what happens with the output? Well, it's going to be even lower. If we decrease the interest rate, this is going to expand my output. So this is going to give us LM prime here, and this is going to be this intermediary guy here. Let's call this guy A prime. And in the first case where we just moved, first of all, we moved only the IS, only with the movement S. Here we had A prime. Okay, let's call this guy A prime, which is the same thing as here. We are calling this guy A prime as well. With this A prime, we have a new level for the output. Oops. Well, no, it's here, right? However, we can ask ourselves, okay, we have already done the monetary policy, which is also an expansionary monetary policy by reducing the interest rate. Can something be done with the fiscal policy? Can I do something with either the taxes or the government expenditures? Yes, it can be done. So let's think about the IS curve. Now you already know, you already know that if I shift the curve here, we are going to have something between Y and Y prime. So we are going to expand the IS. Let's say that we are expanding by increasing the government expenditures or decreasing the taxes. Here's the same thing, right? Then we have this new guy here, and the equilibrium is going to be here. which is the point where the two new curves are going to match. So, as you can see, both of them are giving me the same thing, right? In terms of we start, so we called S and R, let's call X and W, right? What is X is the monetary policy, which is X here, and this is W, right? Those are the two movements. As you can see, the movements are the same. However, in the first case, we have a combination of, because we are, first of all, we are changing the government expenditures. So for a while, there's no change in the interest rate, right? We stick with this interest rate. And then we achieve this new point of equilibrium with a lower interest rate and a greater output. This is different of what happens here in the second case, where we started with the monetary policy. When we start with the monetary policy, we reduce the interest rate, right? The interest rate goes from here to here, and we are in this point. In this point, we have a lower interest rate and a greater output, okay? So this is the only difference, and I wanted to show you guys the two possibilities, because there's no order to do the mix of the policies. However, if we start with one of them and follow, and the second one is we follow the first movement with the second movement, but if you start with either one or the other, during this what we call the dynamics, right? You have one equilibrium and another equilibrium. What's the dynamics between these 2 points? Well, something is different between these 2 points. Qualitative in terms of the results, we have the point B is a point of a greater output and a lower interest rate in both cases. But A prime is a point of a lower interest rate and a greater output in this second case, but the same interest rate and a greater output in the first case, right? This is just to emphasize that you must do the things step by step, right? The guy that's choosing the policies, the policymaker, right? This guy must think, what must be done right now? Should I move the fiscal policy? Should I do the fiscal policy? Should I do the monetary policy? What can be done right now? So the example of the book starts with the fiscal expansion shifts the IS curve to the right, and then the monetary expansion shifts the LM curve down. So if you think about the intermediate steps, the first thing is this movement of the IS curve. So for a while, we stick with this A prime, and then let me call this B because the final equilibrium is A prime. We stick with this B for a while, and then we have the A prime as the final equilibrium, okay? Here we have something about the recessions. I definitely recommend you take a look on that. Here we are using the mix, but this is something that's called this is something that is a combination of the fiscal consolidation and a monetary expansion. Well, the fiscal consolidation is something that's going to, we have G minus T, right? And this is going to shift, we are reducing this combination, and it's going to shift the IS curve to the left, right? Either because you are reducing G or increasing T, right? These two are fiscal contractions. And when this parenthesis altogether reduces, this is the so-called fiscal consolidation. So the fiscal consolidation shifts the IS curve to the left. And if we go from A to A prime, which is the first movement, we have the same interest rate between A and A prime. We have the same interest rate. However, we have a very, very lower compared to Y output. Y prime is much lower than Y. So what can be done? Well, after doing this fiscal consolidation, we can say, let's try to improve the economy a little bit So let's do the reduction of the interest rate with the monetary expansion, and it's going to shift the LM curve down, and this makes the point A prime move to A double prime. This is going to be the new equilibrium because you have this new LM curve, right? So we start with A. After doing the first policy, we have A prime. In order to avoid this recession, because this very low output is called recession, we want to increase the output. In this case, this graph stops at the same level of the output. The idea here is the following. This allows for the reduction in the deficit, and the deficit is represented here, right? The reduction of the deficit without the creation of a recession, because you could reduce the deficit without looking at the output. It's just the first part of the movement. It's just this guy here, right? If you do this guy, you are reducing the deficit, but you are creating this gap here, and this gap is the recession. When you use the monetary policy, you bring this guy back here, and when you bring this guy back, you avoid the recession. So if you do the combination of a fiscal consolidation with a monetary expansion, you have the reduction of the deficit without creating the recession. Well, take a look on those focus sections here. And here there's the discussion how the ISLM model fit the facts. I would like you to read this, guys, as well. And that's all for today, guys. See you next time.